Maybe it's been a little while since you thought about z-scores. As a reminder, the z-score formula is the particular value of interest, x, minus the mean, maybe it's population mean, maybe it's a sample mean, divided by the standard deviation. And effectively what it's asking or answering is how many standard deviations away from the mean does a particular data point live? Effectively, how special is this data point? The other thing that we're trying to demonstrate here for you is just as a quick Algebra 1 reminder that if you are given a formula that, say, has 4 terms, then you can rearrange terms and solve for some fourth variable. So effectively, when you're given this z-score formula, as long as you have any 3 of these values, you can solve for the fourth. We've downloaded this data from worldpopulationreview.com. It is the 2024 largest 400 populations in the United Kingdom. It provides the population, the latitude, and the longitude. And what we've done is we've set it up here in Google Sheets. We have a mean population for the 400 largest cities or townships, whatever, in the UK of 113,708 and a standard deviation of 389,690. This is real data that we're working with. And we wanted to show you quickly how to calculate a z-score in Sheets. As a reminder, we're going to have you Lines on Clay users do this yourselves. We're going to leave this column blank. Here, we're working with population data. We've already done this with the latitude, and we've already done this with the longitude, so you can play along just following us. We're going to put equals parentheses and say, okay, well, here's the population that we're interested in. In this case, it's London. And then we want to subtract the mean. Now, we're going to go in and we're going to put in dollar signs here so that doesn't slip away from us. And then we're going to divide by the standard deviation. Once again, we're going to put in dollars so that the standard deviation hangs out with us. And then from there, Google Sheets says, well, you want me to just fill in all the data? And we say, yep. And so we fill this in. Now, later on in this lesson, we're going to see, okay, hey, well, these are positive and negative z-scores as we scroll down for the population. So for instance, Chelsea in the UK with its population of about 60,000 has a z-score population of 0.138 standard deviations below the mean. London has an insane z-score of 19.1, which we'll get a better sense of just how unbelievable that is. So you can see the next closest as 2.234. But that's how I did it in Google Sheets. I just put in this formula equals my particular data value minus the mean, all in parentheses, divided by the standard deviation. And if I'm going to continue to reuse that, then I'm going to want to use dollar signs. We've given you a nice little calculator and a set of exercises to demonstrate to you Lines on Clay users that if you are given any 3 pieces of data, then it's trivial to just solve for the fourth. In fact, our spreadsheet does it for you. So if you're asked a question and the z-score is 1.25 and the value of x is -3 and the mean is 7, then what is the standard deviation that connects all of these? Well, it's 8. It's just sitting there for you. So we, again, have prepared some questions for you to go in and take a look. And we've also created this demo to keeping things honest. Here we have created a uniform random variable with about 400 values that are always updating. Keep your eye on this list here, these values, and every time I press a number like 1 or 2, they're always changing. And we actually have a nice little visual for you to show that indeed they are uniformly distributed between 0 and 100, which is how we set them up. And the way we've done this is every time we press the button, we are updating, well, what's the mean of the new data set? And what's the standard deviation of the new data set? And we're given new data. Right now, that's 88.89. If I press a button, it's going to be something else. It's 11.113. If I press it again, it's going to be 81.198. And this column C gives us the corresponding z-scores for all of our data. So for this particular data set, a value of 65.583 corresponds to a z-score of 0.566. So what we want you to do is just notice the relationships between these 4 boxed values, the mean, standard deviation, the raw value, and the corresponding z-score. And what we've done is In these columns, we have entered in very specifically the data value, like A equals A20. Well, X equals A20. Well, there's A20. Mu equals E19. Well, what is E19? That's mu. And standard deviation equals E20. So that's the standard deviation. But when it comes to the z-score, we're actually just calculating the z-score the way that we're supposed to do it. In other words, we're not just referencing some value. And what we find is that the z-score that we calculate matches with the z-score down here, which is to demonstrate that these four values are all connected to each other. Given any three, we're going to get the fourth. We invite you just to kind of play around and press 1, 2, 3, go on in, and notice that the values all line up. 50.95, 50.95, 62.883, and 62.883, and so on.